How do you design and build a $2.2 billion National Football League NFL stadium that can keep more than 50,000 spectators warm and safe through Buffalo's notorious winters? That is the challenge currently facing the Buffalo Bills and their ownership group. The team has embarked on one of the most complex construction projects in NFL history, what will become Highmark Stadium, a venue uniquely designed to endure snow measured in feet rather than inches, wind that can push against structures like a constant force of nature, and temperatures that can plunge well below zero. This project is unlike the typical stadium developments we've seen in cities like Las Vegas or Miami, where engineers focus on managing extreme heat or humidity. In Buffalo, the problem is the polar opposite. How do you engineer a massive football fortress that resists relentless snowfalls, bitter winds, and the damaging effects of freeze-thaw cycles on concrete and steel, all while ensuring thousands of fans enjoy the experience in relative comfort? The Bills' new home, expected to be the most ambitious cold-weather football stadium ever built, is forcing both engineers and NFL officials to rethink what it means to construct a modern sports venue in an extreme climate. But as construction milestones shift and schedules slip, the project is also revealing something larger about the broader realities of today's stadium building era. These are not just concrete and steel shells for games, but billion-dollar test cases for innovation, economics, and fan expectations. A stadium opening unfinished. According to John Pula, the Bills' vice president of stadium operations, the plan is for the new Highmark Stadium to be substantially complete by July 2026. That phrase, however, comes with a caveat. While the building will be ready to host NFL games at the start of the 2026 season, it won't actually be fully finished until several months later, December of that year. In practical terms, this means fans will be walking into an operational but still incomplete stadium. Construction crews will continue working through the season, handling punch list tasks such as painting, finishing interior walls, and other detail work, even as tens of thousands of people file into the stands each week. This type of staggered timeline isn't unique to Buffalo. Other franchises have faced similar pressures. The Tennessee Titans, for example, are currently pursuing their own $2.1 billion stadium project, and their construction schedule has already drawn comparisons to Buffalo's. But here's the difference. Nashville enjoys a much milder climate, meaning workers can push forward year-round. In Buffalo, the effective construction season is much shorter. At best, engineers and laborers get about 7 months of reasonably workable weather before cold, snow, and ice make progress difficult or impossible. That constraint puts enormous pressure on project managers to maximize productivity during warmer months, while also accepting that certain tasks simply cannot be finished until after the team is already playing in the venue. The snow melt system, a first-of-its-kind solution, one of the crown jewels of Buffalo's stadium engineering effort, is what Bills officials are calling the largest snow melt system in the world. Unlike the heated sidewalks you might find around northern office buildings or airports, this is a massive integrated thermal system woven throughout the facility's infrastructure. The system is designed to manage the sheer volume of snow Buffalo regularly receives. This isn't about melting a dusting of snow after a flurry. It's about handling lake-effect snowstorms that can drop several feet in a matter of hours. Past and NFL venues have been forced to postpone games or close sections of their stadiums because of snow accumulation. The Bills want to ensure that never happens in Orchard Park. The snow melt system, however, is just the beginning. The exterior of the building is another example of creative engineering. Instead of traditional brick, which provides poor insulation and struggles against freeze-thaw stress, the Bills are using large prefabricated concrete panels designed to mimic brick aesthetically but perform far better thermally. These panels lock into a steel framework surrounding the entire stadium, creating a tough, insulated barrier that not only resists cold, but also ties the building's look to Buffalo's architectural heritage. Financial stakes. The Pegula's massive risk. The stadium project began with a $1.4 billion budget, but as costs escalated, the Bills' owners, Terry and Kim Pegula, have been forced to cover overruns themselves. With current estimates at $2.1 to $2.2 billion, The Pegulas have already absorbed roughly $700 million above the initial plan. To put that into perspective, Forbes estimates their combined net worth at around $5.8 billion. That means more than 10% of their total wealth is now tied up in a single stadium project, an unusually high level of personal financial exposure for NFL owners. Contrast that with other recent stadium efforts. Allegiant Stadium in Las Vegas, home of the Raiders, actually finished $25 million under its $2 billion budget. Meanwhile, SoFi Stadium in Los Angeles became the most expensive stadium ever built, ballooning to $5.5 billion, but it serves two NFL franchises, the Rams and Chargers, and doubles as a massive entertainment complex. Buffalo Stadium, on the other hand, is for a single team in a relatively small market, with limited additional commercial development opportunities. Sports economist Dr. J.C. Bradbury of Kennesaw State University notes that cold weather facilities almost always exceed budget projections. Special requirements for heating, snow load tolerances, weatherproof materials, and long-term maintenance inevitably drive up costs. Bradbury estimates that overruns of 20 to 30% are common for projects in extreme climates. In that sense, Buffalo's budget creep is not unusual, it's practically expected. Why cold weather stadiums cost so much more? Buffalo's stadium illustrates a larger truth about NFL expansion and facility modernization. Warm weather cities, Las Vegas, Los Angeles, Miami, have different and often less expensive design challenges. Cold weather projects like Buffalo's must contend with issues that can quadruple the cost compared to a stadium built in mild conditions. The Cleveland Browns, for instance, are exploring a $2.4 billion domed stadium in Brook Park, which will face many of the same winter engineering hurdles. The Chicago Bears, too, are weighing stadium options that would require extensive climate proofing. Buffalo's project is quickly becoming a case study for what northern franchises should realistically expect: higher costs, longer timelines, and massive logistical challenges. The NFL, for its part, has been forced to adapt. The Jacksonville Jaguars already plan to play with reduced capacity during their renovation in 2026 and may relocate games in 2027. The league appears increasingly flexible in accommodating construction disruptions. Yet Buffalo presents unique scheduling challenges. The Bills' legendary home field advantage comes specifically from their brutal December and January weather. Relocating games to neutral or indoor venues during that period would erase one of their biggest assets: the long-term costs. Of course, these design decisions don't just raise construction costs, they also guarantee higher operational expenses. Heating such a massive structure, running the snowmelt system, and maintaining weather-resistant materials will cost far more on an annual basis than maintaining a warm-weather stadium. The Pegulas are betting that improved fan experiences, comfort, safety, modern amenities will translate into greater ticket sales, premium seating demand, and long-term revenue. But the gamble is even riskier in Buffalo than in larger markets. The city ranks only 38th in the U.S. by population among NFL metros. When adjusted for market size, Buffalo's $2.2 billion project is the financial equivalent of New York or Dallas teams building a $4 billion stadium. That raises a tough question. If small market franchises must spend this much to stay competitive in the facilities arms race, how sustainable is that model? The Packers and Bengals are both evaluating major stadium upgrades, and they will likely face similar challenges. A construction feat beneath the surface. The scale of Buffalo's construction effort is enormous. Crews are using 4 massive cranes to assemble the concrete superstructure. Nearly 800 drilled piers will support the foundation, accounting for Buffalo's freeze-thaw soil conditions that can crack and destabilize inadequately engineered bases. More than 400,000 cubic yards of dirt have already been moved, an operation that underscores the sheer physical complexity of building in Western New York. Every step of the process reflects the difficulties of working in a climate where snow, ice, and wind aren't occasional inconveniences, but baseline realities. The work underway is not only about delivering a single stadium, but about pushing the boundaries of what's possible in cold weather sports architecture. The bigger picture: sustainable or unsustainable. As the Bills push forward, their project is becoming a proving ground for how the NFL handles future cold weather builds. The lessons learned here will influence decisions in Cleveland, Chicago, Green Bay, Cincinnati, and beyond. Will Buffalo's $2.2 billion gamble be remembered as a bold success that redefined cold weather stadium design, or as the moment when engineering ambitions collided with economic reality? The NFL world is watching,